Hello, my name is Martin Mirchev. I'm from National University of Singapore, and I'm going to present to you Cerberus, a program repair framework. This is a joint work with Ron Sharafdin, Yannick Noller, and a big repository. Before we present Cerberus, let's give a bit of an overview on why we need such a tool. In the past years, the automatic program repair field has been growing quite fast. There have been numerous tools released, each focusing on different classes of bugs, different languages, and different sectors. Now, this sounds all great, but that means there's a lot of tools and one has to learn how to interact with all of them, how their APIs work, what are their dependencies, and also how to set up instrumentation if the tool requires such. We thought about this issue and how to solve it, and we figured out that providing an orchestrator to hide all of the complexities of these tools and make things easier to set up would be quite nice to have. We would also like to focus on caching the environment, making sure that after you build a project, you don't need to build it a second time if there have been no changes. This is why we propose Cerberus. Using a stacking of containers and a bit of more details, which we leave out for a paper, we focus on making a good, pleasant experience for developers. Now, having all of this said, we'd like to mention that Cerberus has a lot of tools supported with various different types of benchmarks, and this will show this in a demo. In the demo, I will present to you Profit and Extract Fish, which are tools that repair vulnerabilities in C programs. Verifix, which repairs programming assignments. And Hippodrome, a tool for statically repairing concurrency bugs in Java programs. We will use this on a Apache Tomcat vulnerability. This one, Profit, on the 828 tool from the vulnlog benchmark. This is a vulnerability in libtiff, as previously mentioned. As you can see, Cerberus is started up. It is preparing the environment needed, building containers, and everything required. You can also see that there are a couple of different metadata things, like where are the logs stored, where are the artifacts stored, what is the timeout period. This also can be changed through this profile identifier, as I'm going to show in another example. Profit is already running, so let's start up also extract fix for the same vulnerability. The goal is to show that one can run multiple tools on the same experiments without any file conflicts. I'll also run multiple bugs in a batch mode. I'm going to send them to the Verifix tool, and these bugs are from the ITSP benchmark. I'll also run the Hippodrome tool with a different profile identifier on the Apache Tomcat project. Now, all of this looks quite nice, quite simple, but what has been hidden? Why would Cerberus be useful? Well, these are all the commands needed. One has to set up a lot of things to run these tools. For example, Profit requires a configuration file, a couple of arguments. One needs to understand what these arguments mean. Similarly, Hippodrome has only a configuration JSON file, but one needs to understand what is required there. Verifix's command looks quite big, but in the end there are only 2-3 things that have to be modified. Similarly, extract fix looks also quite simple. The command looks very small, but one needs to understand what the configuration flags mean, and that there's also this implicit project structure required from extract fix to make everything work. Now, this looks nice, and as we can see here, the Verifix tool has already finished its first experiment and has ended successfully. One would also like to see the different artifacts, so I'm going to show one of them. In the artifacts folder, as you can see, each run has its own unique identifier to ensure no conflicts. I'm going to open up a previous instantiation of the Profit tool. This generated 6 patches, and one can easily check them and read what exactly has happened. This is one of the patches generated by Profit. Now, we have left some of the tools to run until the end, and we can see this unified output. How many patches were generated, how much time it took exactly for the tool, how much time it took for the validation, for the build, the exact amount of the search space that was enumerated, that the logs were stored, the exact profile of the logs. This is one of the strengths of Cerberus. Having this unified output means that one can get a high-level overview without too much difficulty and be able to quickly compare tools and results from experiments. Thank you for watching our demonstration video. Link to the artifact is provided below as a QR code.